Today I'm going to discuss about the lapse rate of the atmosphere. If we encountered the term, so what is actually the lapse rate? The term lapse rate means either there is increase or decrease in temperature. Either there is increase or there is decrease in temperature in the atmosphere. And this increase and decrease of temperature actually depends on the height. If you move from the ground surface upward, there will be either increase in the temperature or there will be decrease in the temperature as well. Though according to some scholar that the decrease of the temperature with increment of the height, that is a natural phenomenon. So the abnormal phenomena is that if we move upward from the ground surface, if there is increase in the temperature, that will be known as the abnormal phenomena. In the case of the lapse rate, if we encounter the term lapse rate, it is classified into two types. One is the normal lapse rate, and another is the adiabatic lapse rate. So one is the normal lapse rate, another is the adiabatic lapse rate. So firstly, I am going to discuss about the term normal lapse rate. If the temperature of the atmosphere decreases at the rate of 6.4 degrees C per kilometer with the increase in height, that will be known as the normal lapse rate. Now my question is, if you move upward from the ground surface to the top of the atmosphere, there will be so many layers starting from this troposphere, stratosphere, mesosphere, thermosphere, exosphere, etc. etc. But to what extent, or the question is, in which layer of the atmosphere the condition of the normal lapse rate is very much true. It means whatever the amount of the normal lapse rate we are encountering here, in which layer of the atmosphere this value we are obtaining, that's a huge question. First of all, if I come to troposphere, the height of the troposphere is basically variable from the equator, it means 0 degree, to 90 degree, it means pole. From equator to pole, there is variation in the height in the troposphere, or better say in the tropopause. Generally, if you go to equator, at the equator, the height of the tropopause is close to 17 kilometer. And if you go to pole, the height of the tropopause becomes 9 to 10 kilometer. Even in some cases, it becomes 12 kilometer. So there is variation in the height of the tropopause from equator to pole. Now, in the troposphere, if from the ground surface, if we increase the height, there will be decrease in temperature at a particular rate. Now, what is that rate? In some of the books, it is written that the value is 6.5 degrees C. In some of the books, it is written at 6.4 degrees C. In some of the books, it is written as 6.6 degrees C. Now, which value is correct? Which value is correct? First of all, I am trying to make it very, very clear that the normal lapse rate value, whatever the value is written in different books, that is not the exact value. Actually, that is not the absolute value. That's a relative value. And that's basically an average value. It means we have taken the observation of the normal lapse rate in the different places of the earth, mainly in the troposphere. Suppose at a particular place A, the value is 15 degrees C per kilometer. It means if we increase the height of 1 kilometer, there is decrease of temperature at the rate of 15 degrees C. Suppose at the place B, the value is 2 degrees C per kilometer. It means at the B place, if we increase at the height of 1 kilometer, the temperature will decrease at the rate of 2 degrees C per kilometer. So this is the scenario of the two places A and B. So from there, one thing is very, very clear that the normal lapse rate, whatever the value of normal lapse rate we are obtaining, This value is not the absolute value, this is the average value. It means we have got the observation of the different places of the of this normal lapse rate value. Of the normal lapse rate value, we have got the observation for the different places. Now we have made the average or the mean value, and this mean value is basically the normal lapse rate. Maybe in our troposphere there is no such place where the value is 6.4 degree C or 6.5 degree C per kilometer, the value of normal lapse rate. Maybe in nowhere in troposphere the value is 6.4 or 6.5 or 6.6. Why I am saying this? Because this value is basically the average value. So this average value we have identified on the basis of the observation in the different places, right? So this is the case of normal lapse rate. Now if I come to troposphere, just we have increased the height of the troposphere. So this is the height. So if we have increased the height, there is a decrease of the temperature. Look at the graph. The graph is inclined towards the negative value. It means the temperature value is continuously declining. Now if you come to stratosphere, with the increment of height, there is an increase in the temperature, which is because of the higher concentration of the ozone gas in the stratosphere. Because of that, at the height of 30 to 50 kilometer from the ground surface, there is a layer where the ozone concentration is high. That layer is known as the ozonosphere. So that layer will be known as ozonosphere, where the concentration of the ozone is maximum. Okay. Now, from that discussion, we can classify the normal lapse rate into three types. One is the positive normal lapse rate. Second is the negative, and third is the zero. First of all, I am starting from the negative one. Negative normal lapse rate means with the increase of height, if the decrease of temperature is true, it means we have increased the height, the temperature is declining. If that scenario is true, it will be known as the negative normal lapse rate. If the situation becomes reverse, it means with the increase of height, there is increase in the temperature. I have stated earlier that if there is increase with the height, if there is increase in the temperature, that scenario is known as the abnormality in the atmosphere. In the terminology of the temperature, it is known as inversion. So in the inversion of temperature, with the increase in height, there is an increase of temperature. So that is known as the inversion in temperature. Sometimes that inversion of temperature becomes true in the case of the troposphere. It means that inversion of temperature happens in troposphere, and throughout the year, the inversion of temperature happens in the upper part of the stratosphere where the ozone concentration is high. It means in the upper part of the stratosphere, the inversion of temperature of phenomena is true throughout the year. That is known as the upper air inversion. That is known as the upper air inversion of temperature. Okay. Now, this is positive, and negative means that is the normal phenomena. It means with the increase in height, if there is decrease in the temperature, though at a different rate, it will be known as the negative normal lapse rate. What is the meaning of zero? It means with the increase in height, if the temperature value remains constant, it means there is no change in the temperature value, it will be known as the zero normal lapse rate. Zero means it will be known as stagnant. It will be stagnant normal lapse rate, right? Okay. Now, if the solar radiation is incidenting on a particular surface, there are so many expression of that solar radiation. So if we consider that the incoming solar radiation is the incident energy, IE, incident energy, I for incident, E for energy, incident energy, there will be several expression of this incident energy. The first one is the absorbed energy. It means the energy which is being absorbed by the earth's surface. So that will be known as the absorbed energy. Plus, a particular portion of the energy is transmitted through the earth's surface. So I am writing it is transmitted energy. So a part of the energy is being transmitted through the earth's surface, so that is known as the transmitted energy. Plus another part of the energy is reflected, so that will be known as the reflected energy. So a part of the energy is being reflected, and another energy which will go to the upper atmosphere after satisfying the need of the earth's surface. It means once the earth's surface becomes warm, a particular part of the energy will move to the upper atmosphere. That will be known as the emitted energy. So absorbed energy, transmitted energy, reflected energy, emitted energy. So incident energy may be classified into these four types. Now, again, I am coming to the concept of the normal lapse rate. This normal lapse rate actually varies from one place to another place. If I take three examples, one is the desert area, another is the glacial topography. Glacial and periglacial, I am considering in a same meaning. So one is the desert, another is the glacial. Suppose another is a homogeneous normal topography or natural topography. Homogeneous natural or the normal topography. So these are the three variations in the topography. One is the desert, glacial and homogeneous. You will be surprised to know that the rate of the normal lapse rate is maximum in the case of the desert area. So in the desert area, if you increase the height from the ground surface, the rate of decrease of temperature is maximum. In the case of the Sahara desert, if you increase the height of 1 kilometer from the ground surface, the temperature decreases at the rate of 25 degrees C per kilometer. That is quite surprising. So in the case of the Sahara desert, suppose this is the ground surface. From the ground surface, if you move 1 kilometer upward, suppose at the level of the ground surface, the temperature of the air is 40 degrees C. So after 1 kilometer of ascent, if you move 1 kilometer upward, the temperature value will become 15 degrees C. So after 1 kilometer of ascent, the temperature of the air decreases at the rate of 15 degrees C per kilometer. So that is in the case of the desert, and it is the example of the Sahara desert. The situation is more or less true for the entire hot desert, but the situation will be different for the glaciated topography or for the cold desert. In the case of the glaciated topography, the rate is minimum. It means in the case of the glaciated topography, if you rise 1 kilometer upward from the ground surface, the rate of decrease of temperature is 2.5 degrees C on an average in the case of the glaciated topography. Suppose the temperature value at the surface of the earth is 2 degrees C, maybe it is 2 degrees C. So after 1 kilometer of ascent, it will become minus 0.5 degrees C, because the temperature value has decreased at the rate of 2.5 degrees C per kilometer. At the ground level, the temperature value was 2 degrees C plus 2 degrees C, and after 1 kilometer of ascent, the temperature of the air declined only at the rate of 2.5 degrees C per kilometer. So the temperature value we are obtaining, it is minus 0.5 degrees C. So one thing is getting very very clear, and this is the essence of the normal lapse rate, that normal lapse rate, it is not fixed, it is not a fixed, and whatever the values, those are written in the different books, maybe 6.4, maybe 6.5, maybe 6.6. This is not the exact value, this is the average value. So this is the scenario of the normal lapse rate. Now I am going to discuss another very important topic. So what are the controlling factors of the normal lapse rate? First of all, I am coming to the radiation. If I consider that this is the ground surface, so near the ground surface, there are so many dust particles, water molecules, hygroscopic nuclei, condensation nuclei, etc., etc. Those are available near the ground surface. Here I want to mention a distinction between the hygroscopic nuclei and condensation nuclei. Hygroscopic nuclei is responsible for the condensation near the ground surface. So near the ground surface, hygroscopic nuclei will take the most pivotal role for the condensation. It means if you consider the fog, if you consider the dew, those are the forms of the condensation near the ground surface. Hygroscopic nuclei takes the most pivotal role. Now, what is condensation nuclei? Condensation nuclei means the nuclei which are responsible for the condensation at the upper level of the atmosphere. So if you consider, if there is a cloud, so for the formation of the cloud, as all of you know that the cloud is the form of a condensation, so this form of the condensation or cloud is possible because of the presence of condensation nuclei in the atmosphere. However, near the ground surface, the amount of the particles, hygroscopic nuclei, condensation nuclei, all these things are very much higher. So when the solar radiation is incidenting on the ground surface, maximum part is absorbed by these dust particles, condensation nuclei, and most importantly the water vapor. So all these are absorbing this reflected solar radiation by the ground surface. Not only the reflected, even the incidenting solar radiation is being absorbed by these dust particles, right? So near the ground surface, the temperature of the air will be higher. Why higher? Because of the higher amount of the condensation nuclei and the other particles, uh, maybe hygroscopic nuclei, dust particles, water vapor, etc., are available near the ground surface. They are absorbing the solar radiation, so the temperature is high near the ground surface. The amount of the condensation nuclei is less near the ground surface because the amount of the condensation nuclei is high at the upper atmosphere. Thus it is responsible for the condensation in the upper part of the atmosphere. Cloud is the best example of that. However, so if you move upward from the ground surface, the amount of these particles declines, so automatically the temperature value will be less. So that is one of the most important reason, that because of the less number of these dust particles, they are not able to absorb the reflected and the emitted solar radiation. Now because of this fact, the amount of the temperature at the upper part of the atmosphere is found to be very less. Due to that reason, if we increase the height from the ground surface, the temperature declines. And that is the scenario of the normal lapse rate. Secondly, I am coming to the topographic character. Topographic character, I have mentioned earlier. If you consider the desert topography, where the ground surface is covered by the sands, and whatever the amount of the solar radiation that is incidenting on the surface, maximum amount of the solar radiation is absorbed by the sand particles. Now if you move upward, the number and the it means the amount of the sand particles are very less, found to be very less, so they are not able to absorb the solar radiation, so automatically the temperature will be less over here and the temperature will be high over here. For that reason, I am giving you one example for the Sahara Desert. In the Sahara Desert, the amount of this normal lapse rate is found to be 25 degrees C per kilometer. It means if you move upward 1 kilometer from the ground surface, the temperature falls at the rate of 25 degrees C. Okay, acha. But it doesn't mean that after another kilometer, the temperature will fall at the same rate. Remember this one. Suppose at the ground surface of the Sahara Desert, the temperature is 40 degrees C. After 1 kilometer, the temperature will become 15 degrees C, because 40 degrees C minus 25 degrees C, the temperature value is 15 degrees C. After another kilometer, it means after 2 kilometer from the ground surface or 1 kilometer from this value, it doesn't mean that the temperature value will decline at the rate of 25 degrees C. The temperature value may decline at a different rate. Okay, this is the peculiarity of the term normal lapse rate. For that reason, the normal lapse rate concept is very crucial, and this concept is also very mysterious. It becomes very variable in the case of the climatology, right? Okay, so that is the situation of the topography. In the case of the desert, the value is higher. NLR value is higher. In the case of the glaciated topography, the value is very less. The average value is 2.5 degrees C per kilometer. And if you go to on an average place, neither desert nor cold desert, so in that place the value is actually close to 7 to 8 degrees C. That is also the average value. Okay, 7 to 8 degrees C per kilometer. Okay, so that is the topographic character. Now I'm coming to atmospheric composition. Atmospheric composition means near the ground surface, the percentage of these dust particles, water molecules, etc., are very higher. So they are absorbing the solar radiation at a very much faster rate. So the temperature near the ground surface is high. I have already stated earlier about this fact. Conduction. In the atmosphere, there are two very important processes, and it has become a matter of confusion for the students. One is the conduction, and another is the convection. Remember, these are the two terms. Convection means, say for example, if this is a ground surface, the solar radiation is incidenting onto the ground surface, the air near the ground surface becomes very warm, very warm. And if the temperature of the air becomes very high, this air will move in the upward direction. Why this air is moving in the upward direction? Because the temperature of the air becomes very high near the ground surface, as that air has absorbed the solar radiation. So this air has become warm, so there will be generation of the low pressure because the air has become warm. So there will be low pressure. Now the air is moving into upward direction, right? So since the air is moving in the upward direction, this phenomena is known as convection. During the summer time, or during the pre-monsoon time, or during the springtime, in the case of the cooler climatic areas, the convection process is very active. It means from the ground surface, the air moves, the warm air moves in the upward direction, and it is responsible for the generation of the cloud, and ultimately there will be rainfall. So convection is a process by which we can get the rainfall in the different geographical areas. From that term convection, we have encountered another term, that is the convectional precipitation. Convectional precipitation or convectional rainfall. However, there is another term that is known as the conduction. What is the meaning of conduction? Conduction means, if the air, if a particular air from place A is moving towards the place B, and suppose the temperature of the air which is moving from the place A, the temperature is 40 degree, and the temperature of the air, the persisting air or the existing air at the place B is suppose 25 degrees C. So this air is moving from this place to this place. So automatically this air will carry the higher temperature to the place B, because this air is moving from a temperature of 40 degrees C, and it is moving to another place where the temperature is 25 degrees C. So this air will have a tendency to carry this 40 degrees C temperature to the place B, with the intention to make the homogeneity in the temperature character of the air. So this air has a tendency to make the temperature of the place A and place B equal or homogeneous. So conduction is the process in which there is a transfer of temperature from one place to another place. That is the meaning of this term conduction. Conduction is a very important process by which the less temperature from pole is transported to the place of the temperate areas, and the higher temperature from the tropics moves to the lesser temperature of the temperate belt. So due to that reason of conduction, and convection is the process by which there is a formation of the rainfall or precipitation, since the air moves in the upward direction. Okay, that is absolutely fine. Now this is the scenario of normal lapse. Now if I come to another concept, since we have classified the lapse rate into two types, one is the normal lapse rate, another is the adiabatic lapse rate. One is the adiabatic lapse rate, ALR. are adiabatic lapse rate. Adiabatic lapse rates is also classified into two types. One is the dry adiabatic lapse rates and another is the wet or moist adiabatic lapse rate. So what is the meaning of the dry adiabatic lapse rate? Dry adiabatic lapse rate means if a parcel of air, suppose this is a parcel of air, or suppose the air is contained in a box, if that parcel of air moves in the upward direction from the ground surface, its temperature will decline at a specific and a fixed rate. In the case of the dry adiabatic lapse rate, this value is 10 degrees C per kilometer. It means in the case of the dry adiabatic lapse rate, if a parcel of air moves in the upward direction from the ground surface, its temperature will decline at the rate of 10 degrees C per kilometer. Not only that, there is another very interesting feature. That feature is that suppose this is the ground surface, this is the parcel of air. Suppose the temperature of the parcel of the air is 40 degrees C. It is moving in the upward direction and the height is 1 kilometer. So the air parcel has moved to the elevation of 1 kilometer. According to the concept of dry adiabatic lapse rate, the temperature of this air parcel will decline at the rate of 10 degrees C. So here the temperature of this air parcel will become 30 degrees C after 1 kilometer of ascent. But this decline in temperature is not due to addition of heat, not subtraction of heat. No addition, no subtraction of heat. This decline in the temperature is because of the expansion. So previously this was the size of the air parcel and now this is the size of the air parcel. Look at the expansion of the air parcel. It means that 40-degree temperature has converted to 30-degree temperature since this air parcel has expanded in volume. Now my question is why this air parcel has increased in volume. Say for example, this is the ground surface, this is the parcel of the air. Here the air parcel was in a deep pressure. The pressure is being obtained from the dust particles, water molecules, hygroscopic nuclei. So from everywhere this air parcel is getting a pressure. Okay. Now when that air parcel moves in the upward direction, it will be expanded. Why? Because there will be lesser pressure exerted by the dust particles. Why? Because of the less number of the particles available in the upper part of the atmosphere. So this air parcel will increase in volume because the pressure exerted by the dust particles will decline with the increase of height because of the less number of the dust particles, and most importantly the thickness of the air has declined. Thickness of the air has declined. Due to that reason the air parcel has expanded in size. Most importantly, the rate of dry adiabatic lapse rate is 10 degrees C per kilometer and this value is fixed in the different geographical spheres. If I consider the desert, if I consider a glaciated topography, if I consider a normal topography, it means non-desert, non-glaciated topography, everywhere the value is fixed at all levels in the atmosphere. At all levels in the atmosphere. It means if you move upward, this value, this decline rate will remain stagnant, not like the normal lapse rate. Why? Because the normal lapse rate is varying from one place to another place, but here dry adiabatic lapse rate will become stagnant from one place to another place. That is the speciality of the dry adiabatic lapse rate. Now I'm coming to the next concept, because the adiabatic lapse rate was classified into two types. One is the dry adiabatic lapse rate, and another was the wet adiabatic lapse rate. If I consider the wet adiabatic lapse rate, wet adiabatic lapse rate's value may vary from 5 degrees C. In some of the books, the value may be written as 5 degrees C per kilometer. In some of the books, it may be written as 4.5 degrees C per kilometer. In some of the books, it may be written as 5.5 degrees C per kilometer. However, this is also the average value. This is not the fixed value. And most particularly, what is the wet adiabatic lapse rates? Say, for example, if we consider the ground surface, this is the air parcel. Say, for example, the temperature of this air parcel is 10 degrees C at the ground surface. If this air parcel move upward up to the height of 1 kilometer, so according to the rate of the dry adiabatic lapse rate, the value of the air parcel will become 0 degree C, and the air parcel will expand it in size. Why it becomes 0 degree C? Because the temperature rate declines at the rate of 10 degree C per kilometer. After another kilometer, this temperature, it means the 0 degree temperature, will be converted to minus 10 degree C, following the rate of 10 degree C per kilometer of the adiabatic lapse rate, better say dry adiabatic lapse rate. Now, if there is a condensation at this particular temperature, minus 10 degrees C, so in the upper part of the atmosphere, it is quite expected that at the temperature of minus 10 degrees C, there will be a greater chances of condensation. So after condensation, the latent heat is released from the condensed body. It means when the water condenses, if this is a water particle, if it becomes condensed to form the hell, one temperature will be removed from the body of the hell. That temperature is known as latent heat of condensation. Latent heat of condensation. So once that latent heat of condensation is released from that condensed body, it is again moving to the upward direction, and most importantly, that latent heat will be responsible for increasing the temperature of the surrounding body at the height of 2 kilometer. At the height of 2 kilometer. Okay. Now the temperature of this ascending air, better say this latent heat of condensation, this air is moving in the upward direction, because I have mentioned the term heat, so it will be mentioned in the concept of the warmness. So that air is moving in the upward direction, this latent heat. Now the temperature of the latent heat will be declined either at this rate, at this rate, and this rate. If I draw a cloud, suppose this is a cloud, and within the cloud, if the water molecule is converted to hell, if the water molecule is converted to hell, from the body of the hell, the heat of condensation latent heat of condensation will be released from the body of the hell, and it will move from the body of the cloud. It will move from the body of the cloud, and it will make a crack at the body of the cloud, and that crack position is known as the anvil. Okay. So this is the scenario of the dry adiabatic lapse rate and wet adiabatic lapse rate. And previously I discussed about the term normal lapse rate. So in our today's lecture, I have discussed about the normal lapse rate, dry adiabatic lapse rate, and the wet adiabatic lapse rate. In my next class, I will be discussing about the concept of stability and instability of the atmosphere. Thank you all of you for your patience.